So here are the most common misconceptions people have, and I just wanted to run through them. So if this was a question that the 95% confidence limits for relative risk of heart disease for individuals who are obese compared to non-obese individuals is 1.21 and 6.91. And is there a relationship between heart disease and obesity? And often people will say, I can't tell you that because I don't know what the relative risk is. There's not enough information to tell, you didn't give me the relative risk. That is not the correct answer. The correct answer is yes, there is. And the reason I know there is because a relative risk of 1 means the risk of the exposed and the unexposed is the same, right? Because it's exposed divided by unexposed. If the relative risk is 1, that means it's the same. If the 95% confidence interval goes from 1.21 to 6.91, 1 is not in that interval. So that means that there is a significant relationship, that 95% of the time, the population value is between 1.21 and 6.91. Is it 1? Not as far as we know. So you don't need to calculate it from these data. You don't need the data to answer the question. You just need to understand what a confidence limit is and what relative risk is. What do we mean by statistical significance? This is something that people very often get wrong. Like, if we say something's statistical significant, it means we have rejected the null hypothesis. It means that it's highly unlikely that the null hypothesis is true, that there is 0 difference between the means, or there is 0 difference from 0.5, our hypothesis proportion, or that the relative risk is exactly the same, that there's 0 difference between risk of the exposed and unexposed. So that's what it means. That's highly unlikely the null hypothesis is true. So a good question would be, once you have determined something is statistically significant, what should you do next? And the answer is either before or after that, but in addition to determining that something is statistically significant, you should look at how large the difference between means is, or how big the correlation is, or how large the difference between proportions is. So you should always look at those descriptive statistics as well as statistical significance. A mistake people make very often, and ChatGPT may not tell you not to do this, I will tell you not to do this, do not use a t-test unless both your variables are binary, or if both your variables are binary. If they are, don't use a t-test. A t-test assumes that you have one binary variable and you have one continuous variable. Like, is there a difference in age of diagnosis between men and women? So gender, binary, and age at diagnosis is continuous. Is there a difference in depression score between people who have and have not been diagnosed with cancer? You've either been diagnosed or not. You're in 1 of 2 categories. Depression scale is a continuous scale. A lot of them go from 0 to 60 or 12 to 60. So then you'd use a t-test. If both your variables are binary, is there a relationship between having a medical condition and death? Don't use a t-test. Use the chi-square. When to know which is a common mistake that people make. And for some reason, I see people trying to do t-tests when both their variables are categorical. Don't do that. This has to do with your final paper, but I'm just throwing it out here now. If your null hypothesis doesn't mention a variable, do not include it in your analysis. If your null hypothesis is there is no difference in age at diagnosis of heart disease between men and women, do not do a t-test where the dependent variable is BMI. Your t-test has to include the variables in your hypothesis. State your null hypothesis. And this is both for the final and for your final paper. State your null hypothesis. There is no relationship between smoking status and health, rated from excellent to poor. Smokers have no greater risk of asthma than non-smokers. Whatever your null hypothesis, say it. Don't give me the definition of a null hypothesis if I ask you what is your null hypothesis. I already know the definition. And if I didn't, I would look it up on ChatGPT. Should know this. There are more, not if your hypothesis, know how you're going to test your null hypothesis. And if you don't know, ask. There is nothing wrong with not knowing things. Nobody came down the birth canal and said, oh, a z-value of 1.97 is statistically significant. Nobody ever. So if you don't know, ask. If you say there are no more non-smokers than smokers, your null hypothesis then is the proportion of people who are non-smokers is 0.5. This people do all the time. Do not confuse, don't confuse, okay, I meant don't confuse, just pretend I spell it right. Don't confuse a test statistic and a p-value. Yes, I don't know how many hundreds and probably thousands of times I've read papers where somebody said we accept the null hypothesis because the t-value is 2.3 and that's greater than 0.05. No, you don't accept the null hypothesis. The t statistic is greater than 0.05, or you look at the probability of that. So it's the probability of getting a t-value that high. So a p-value, oh, another thing, a p-value is a probability and it cannot be greater than 1. So if you say that the probability is, the p-value is 2.365, you just said there was a 235% chance of this happening. And this is not true. So if your p-value is greater, your probability is greater than 1, there is some problem. Now, sometimes, in fact, you will get that from a computer where you get a probability greater than 1. And what does that mean? It means that there's some error in your program. So if the number, boy, I spelled things wrong here all over the place. If the number you're looking at is greater than 1, it cannot be the p-value. So these are the kind of questions that we're not going to be asking you anymore, like what proportion of women have diabetes, because you could just copy and paste that into something like ChatGPT and get the answer. So, but this kind of thing that requires you to understand actually what's going on in statistics, if your null hypothesis is there's no difference in the odds, then the odds ratio equals 1. And if 1 falls within the 95% confidence limits for the odds ratio, you accept the null hypothesis. So this is exactly what I said at the very beginning when we talk about relative risk. It's the same thing with odds ratio. If the odds are equal, then there's no difference, right? And if 1 falls, so that's the other thing. People often say, well, a null hypothesis is a hypothesis of 0. No, a null hypothesis is a hypothesis of no difference. So if there's no difference in the odds ratio you get is 1, because something divided by the same thing is 1. If 1 falls within the 95% confidence limit, you accept the null hypothesis. So if you got something like this, and I asked you, is there a statistically significant difference between the groups given this odds ratio, what would you say? This gives you the relative risk. This gives you the odds rate. So this is the odds ratio. This is the relative risk, and these are the confidence limits. So if 1.0 falls within these 95% confidence limits for the odds ratio, that means it's a plausible value. It would fall within the values we get in that 95% curve, right? And does 1 fall between 0.82 and 3.6? So since 1 does fall within the confidence limit, 1 is a plausible value. And so, yes, you would accept the null hypothesis and say that it seems that the odds could be equal. Because yes, we got an odds ratio of 1.73, but the 95% confidence limits are 0.82 to 3.6. 1 falls within there. 1 is a possible value that occurs more than 5% of the time. So same thing for relative risk. The relative risk value is 1.1, but the confidence limits go from 0.96 to 1.25. So again, 1 falls within there. So it's plausible. It's within that range of plausible values. That's what the confidence limit is. When it says, when we hear on the news, and we're going to be hearing it so much with the elections coming up, that, this is within the margin of error. In other words, it means that within that 95% confidence limit is 0 difference between those 2 candidates, for example. So here's another one. I did a test of the relationship between vaccination status and measles. And the 95% confidence limits for the odds ratios were 30.5 to 90.4. Would you accept or reject the null hypothesis? And this only is complicated if you don't put it in terms of, does 1 fall between 30 and 90?
No.
Right. That's not a tough question, right? Is 1 between 30 and 90? No, it is not. See, and that's the thing where people often get, you're trying to think, it's got to be harder than that, because I learned that in kindergarten, right? Like my little granddaughters learned to count to 100. No, it's not harder than that. Does 1 fall between those 2 numbers? No, it does not. Then I'm rejecting the null hypothesis. 1 is not within the 95% confidence limit, not a plausible value. So if I asked you why, you would say, because 1 does not fall, an odds ratio of 1 would mean the odds are the same, and 1 definitely does not fall between 30 and 90. So not only is the odds ratio not within the confidence limit, it's not even close. So another one, I conduct a t-test, compares systolic blood pressure in men and women. I get a value, a t-value of negative 0.59, p equals 0.72. Would I accept or reject the null hypothesis? Another really difficult question. Is 0.72 greater than 0.05?
Yes.
Yes.
Right, yeah. So 0.72 is greater than 0.05, then you would accept the null hypothesis, because 0.72 is not less than 0.05. So again, it's not, people think if what I ask them is a trick question. No, 0.72 is greater than 0.05. The probability is greater than 0.05, so we accept the null hypothesis. If I conducted this t-test, what exactly was my null hypothesis that I was testing? Would be an hypothesis of no difference.
No different.
Yeah. So your null hypothesis, you could either say it's that the mean for women equals the mean for men, or there's no difference in the mean systolic blood pressure of men and women, or the mean of 1 minus the mean of 2 equals 0. All of those mean the same thing, really. So however you set it, that would be it. So in the case of a t-test, the null hypothesis is that there's no difference between the means. And again, you may laugh at me when I say these things, but no matter how smart you are, and like I said before, if you have never looked for your phone while talking on it, you are amazing. People do. So people will be computing probability and give a negative number. There's no such thing as negative probability. 0 is it never happens. It cannot happen less than never. There cannot be negative probability. 1 means it always happens. So probability cannot be greater than 1. And I have had people bring to me printouts and say, and they did show them that, that had a probability greater than 1, and say, look, but the computer says so. Well, then it's wrong. Things can be wrong because, it's the old garbage in, garbage out. So if you find a probability greater than 1, there are one of 2 possibilities. Either there is an error in your program, or you're looking at the wrong number, and that's really like the t statistic or the z value. Probability can't be greater than 1.